Noise detection system using Arduino Nano. Hi everyone, my name is Dr. Konark Sharma. In this lecture, we will learn about the basic overview of noise detection system using Arduino Nano from Shan Gupta, Yuvraj Dhamija and Surendra Meena. Upon completion of this lecture, learners will be able to understand about the basic overview of a compact, cost-effective and energy-efficient noise detection system using Arduino Nano. So, let's get it started.
KONARK'S research. Subscribe now.
Hello everyone, we're a team of enthusiastic second year engineering students. We're super excited to present our IoT based project titled Noise Detector with Automatic Recording. In today's world, maintaining a peaceful noise free environment in certain spaces like library, hospital, and study zone is essential. This is where our project comes in handy. We've designed a compact system using an Arduino Nano as the part of our project. It continuously monitors the surrounding noise using a sound sensor, and as soon as the noise exceeds a certain threshold, it automatically triggers a buzzer to alert the nearby individuals. And simultaneously, a Bluetooth message is sent to the Android app. This app records the audio instantly as for proof and evidence for future analysis.
Our aim was to create a low cost, efficient, and responsive system that could serve multiple real life use cases, whether it's ensuring silence in a classroom, or monitoring for loud disturbances in libraries, or even keeping track of unusual sounds at home. This project can be adapted and deployed in various scenarios. It's fully wireless, portable, and beginner friendly, and can be used by anyone, even those with little technical experience. The entire system runs smoothly with minimal components and was tested across different noise levels to ensure reliable operation.
Our system consists of following components: Arduino Nano as the central microcontroller, sound sensor module for detecting noise, Bluetooth HC05 for wireless communications, vibration buzzer for alerts, breadboard and jumper wires for circuit setups. We also developed an Android app that connects with Bluetooth and starts audio recording upon receiving the alerts.
We worked on different parts of the project individually and have brought everything together. Different parts are hardware, software, and we've integrated all of them together. In the next few minutes, we'll be explaining you how and what goes on throughout the project.
Hello everyone, I'm Shan and I was responsible for handling the hardware part of the project. That includes assembling all the electronic components, wiring and connection on the breadboard, and making sure the circuit functions reliably with the Arduino. Our hardware setup is the backbone of the noise detector system. Let me walk you through the process. At heart of our system is the Arduino Nano, which acts like a microcontroller. To detect environmental noise, we use the sound sensor module. It connects to the analog AO on the Nano. The sound sensor continuously reads ambient sound levels and converts them into analog voltage. The Arduino keeps checking this input in real time. However, whenever a noise exceeds the defined threshold, which we have calibrated based on the surroundings, the Arduino sends a message saying noise exceeded. Now, to alert the user when this happened, we connected a buzzer to the digital pin D3 of the Arduino. This buzzer goes off immediately when the noise crosses a certain limit, providing instant audible feedback. We've also experimented with a small vibrator motor as an alternative alert mechanism. Both options work well depending on the environment. And for wireless communication, we've integrated HC05 Bluetooth module, which connects the hardware to the Android app. The HC05 is powered by Android by the Arduino 5V and GND pins. The Bluetooth TX pin, which transmits and connects to the Arduino, and the receiver goes to the D3, which is shared with the buzzer. Since both the buzzer and the Bluetooth are triggered with the same noise level, we use the shared line carefully, making sure that it doesn't affect our performance. All of this was assembled neatly on a breadboard using jumper wires, and we also double check the signals for their stability and voltage levels. To make sure no components get overloaded, we finally ran multiple tests generating on multiple sounds. To make sure the sensors accurately pick up the sudden changes and triggers within the response time. In short, this compact and low-power hardware setup acts as a smart noise detection node that can be used in indoor and outdoor environments. It is modular, scalable, and easy to modify for future enhancements and has a lot of potential.
This right here is a project which we have built on this breadboard. I've connected it to my laptop for power supply. This is the Arduino Nano which we have used for this project. Here we have the Bluetooth HC05 to connect it to any mobile phone for the extra functionality we have added. This right here in the corner is the microphone which will be used to capture those higher levels of noise. This black thing in the bottom is the buzzer which will start buzzing as soon as the noise level crosses a certain threshold, which we can easily set in our code and we can upload it to the Arduino Nano. This project is not a normal simple noise detector which you will see in the market. The one good thing about this is we've added extra functionality in this, that is, as soon as the noise level crosses that threshold, this Bluetooth signal is sent to the mobile device it's connected to, and on that we've built an app which will be running on a local server on a laptop, which when connected to it will start recording. The buzzer will start buzzing as soon as the noise level crosses the threshold, and side by side that mobile app will start the recording, and it will help us to know from where the noise is coming and which all parts need to be taken care of. So I'll give you a demo of how this project works. So right now the buzzer got damaged due to some reasons, so it's not properly making that sound, but here it is. Hello, 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 hello. I'm not sure if the sound is clear enough to be heard through this microphone, but we have set a certain threshold. As soon as the noise level grows higher than that, it automatically starts beeping. And the one good thing is, it's not like it will keep irritating us, because I set the buzzer timer too for how long it will play that sound. Initially it was a little higher for 3-4 seconds, but later I turned it to 1 second because it was capturing every little sound and was making a lot of noise.
Hello, my name is Sundar Meena and I work on an Android application that complements our hardware. We created a simple app using MIT app inverter which allows Bluetooth pairing with the HC05 module. The app UI has a connect button for Bluetooth, and in the background it listens for specific messages that sent by the Arduino. When the sound level is high and the Arduino sends the message like alert, noise detected, recording started, the app receives this message and immediately starts recording using the device microphone. The audio file is then saved locally on the phone or for later playback. We also included manual buttons for stop and start recording in case users want to override the automatic behavior. The UI was kept simple for easy for use, and most importantly, the response time from detection to recording is less than a second, which ensures real-time action. The app is scalable and can be further enhanced to include cloud upload, time-stamping, or even local tagging for more complex use cases.
To conclude, this project helped us gain hands-on experience on IoT, embedded systems, mobile app development, and real-time interfacing. From wiring and coding to building the UI, ensuring reliable communication, we've learned all the parts and all the components required to build such an incredible project. Thank you so much for watching our presentation, and we hope you like it.
Finally, we would like to cooperate with you according to the best of our knowledge. Keep your feedback and suggestions coming. They help us to provide you quality work that resonates with your needs and requirements. Thanks much for sharing your kind suggestions. Keep healthy, keep learning, and keep growing.
KONARK'S Research. Subscribe now.